Hello students, in today's video we are going to see the graphical method derivation for equations of motion. Now there are total 3 equations of motion and we are going to see the derivation for all. So before we start students, there are total 5 quantities what we need to remember. So let me illustrate this with an example. Okay, so we have a road and there is a car moving along a road. So let the initial velocity of the car be u, and if you see, the car is moving from left to right. Now when the car reaches at this particular point, I am accelerating this particular car with an acceleration a in the same direction, means what? Towards right. Okay, so the car is moving towards right. I'm accelerating the car towards right for a given time t. Now since the car is accelerated, now what will happen? The speed of the car will increase. Okay, and say after a certain time t, the final velocity of the car is v. Okay, and after that, the distance covered by the car, let us take that distance as s. Now this is nothing but the displacement. So here if you see in the figure, there are total 5 terms. U, that is initial velocity, a, that is acceleration, t, that is time, v, that is final velocity, and the displacement of the car, that is s. Okay, so knowing these 5 terms, that is u, v, t, a, s. Okay, now let us understand how do we show these terms on a graph paper. Okay, so first I'm drawing a x-axis and y-axis. Now remember students, for the derivation we always plot time on x-axis and velocity on y-axis. So this particular graph, we call it as velocity versus time. Velocity on y-axis and time on x-axis. Okay, so let us take point A, which indicates the initial velocity of the car. So if you see the graph very carefully students, AO is nothing but the initial velocity, which is denoted by u. Now from point A, okay, I am accelerating the car, uniform acceleration for a given time. So if you see the arrow going up, so that is called as a uniform motion, a uniformly accelerated motion. Okay, so let us take point B, which shows the final position of the car. So from B, if I draw perpendicular to y-axis, let that be point E. So EO will show me the final velocity of the car. Okay, and from B, if I draw perpendicular to x-axis at point F, OF will show me the time for which I have accelerated the car. Okay, now from A, if I draw perpendicular to BF, that is AD is perpendicular to BF. Okay, now I can say that AO is equals to DF because it is a rectangle. So DF is also going to be U, that is initial velocity, and BF is going to be nothing but EO, that is V, that is final velocity. Now if you see the graph very properly students, I have shown U, that is initial velocity, V, that is final velocity, and T, that is time on the graph. I have not shown acceleration and displacement. Okay, so further in this video we will see how A and S is to be shown on the graph. Okay, now with this students, let us start with the first derivation. So the first equation is called as the equation describing the relation between velocity and time. Means what? After the derivation you will see that the equation what we get will show us the relation between velocity and time. Okay, let us start with the derivation students. So we know the formula, that is acceleration is equals to change in velocity upon time. So what do you mean by change in velocity? Final velocity minus initial velocity upon time. So instead of acceleration I am writing A, and change in velocity is nothing but final velocity minus initial velocity upon time. Now since students we are doing graphical derivation, I want all of you to look at the graph and see what is the final and initial velocity. So see the next step, A equals to EO minus AO. See the graph, EO is nothing but the final velocity, that is V, and AO is nothing but the initial velocity, that is U. Now from the graph, if you see, if I do EO minus AO, I get EA, and that is what I'm writing in the next step. that is a equals to small a, okay, acceleration equals to ea upon t. Now if I shift t towards a, what I get? ea equals to at. Now when I say at means a into t, okay, so ea equals to acceleration into time. Now again have a look at the graph, students. Can I say that EO, the total distance EO, is equals to EA plus AO? Here it is velocity, okay. So EO is nothing but final velocity V. EA we already found in the step above, that is AT, and AO from the figure again it is U. So if I substitute all the values, what I'll get? V equals to AT plus U, and if I write in the standard form, I get V equals to U plus AT. So this is nothing but the first equation of motion. Okay, now students, before we go to the second equation, I need to understand one thing from this particular graph. Okay, now let's see what I have highlighted with blue. Okay, EA is nothing but equal to AT. So what I'm doing is, when I'm going to the second derivation, instead of EA, I'm going to write down over there AT. So EA is nothing but acceleration into time. Okay, now let's see the second equation. Now the second equation will show us the relation between displacement and time. Okay, and if you see what I've taken from the previous graph, that is nothing but the value of EA, that is AT. Okay, now one more concept we have to understand over here, students, that is the distance traveled by the object from its initial position to the final position. So A is the initial point and B is the final point. And see what I've written: the distance traveled by the object or by the car from point A to point B is given by area under the graph. Now what do you mean by area under the graph? Let's see. Okay, now have a look at the graph, students, very properly. I'm showing you two things. Okay, the green is nothing but a right angle triangle ADB, and yellow is nothing but a rectangle AOFD. So this is nothing but the area under the graph. So from point A and point B, when you draw perpendiculars to x-axis, the area what you get will give you the distance covered. Okay, means displacement. Okay, so let us write down S equals to area of quadrilateral AOFB. Now if you see the figure, if you see the graph, this particular quadrilateral I have divided into two parts. That is the triangle which is shown by green and a rectangle which is shown by yellow. So the next step I'm writing, that is displacement S equals to, or distance equal to, area of triangle ADB plus area of rectangle AOFD. Now in the next step, what we are doing, students, we are just using the formula and substituting the value. Okay, so let's see the next step. So area of triangle is what? Half into base into height. If you see the graph properly, the base is nothing but AD and the height is nothing but BD. And in a rectangle, the base is OF and height is AO. So that is length into breadth. Okay. Now what will you do? We will substitute the values. Okay. Let's understand the next step very carefully, students. So S equals to half AD. If you see the graph, AD is nothing but equal to FO. These are the opposite sides of a rectangle. So I'm, instead of AD, I'm writing T. BD is nothing but equal to EA. Okay, again opposite sides of a rectangle. So instead of BD, I'm writing AT, that is A into T, plus OF is nothing but T, and AO is nothing but U, initial velocity. Now if I just multiply, what I'll get? S equals to half AT square plus UT. So let me write that in the standard form. S equals to UT plus half AT square. This is the second equation of motion. Okay, now let us start with the last derivation, students, that is the third equation. Okay, so the third equation is going to give you the relation between displacement and velocity. Okay, now remember how we started the derivation for the second equation. The same way we are going to start with the derivation for the third equation. Okay, I've written the same statement, that is the distance traveled by the object from A to B in a given time t is nothing but area under the graph. But here, if you see the graph properly, students, I'm showing with red border. Okay, now in the previous derivation I took a triangle and a rectangle separately. Here we are taking the whole figure together. Now if you see the figure very properly, AO and BF are parallel, so this is nothing but a trapezium. So I will say S equals to area of trapezium AOFB. Okay, now I hope all of you know the formula for area of trapezium. Okay, so let me write down. S equals to half of, means the formula for area of trapezium is half sum of the parallel sides. If you see the figure carefully, students, BF and AO are nothing but the parallel sides, and AD is the height. Okay, so now let me substitute the values. So S equals to half of BF is nothing but V, final velocity, AO is nothing but U, and AD, which is the height, is nothing but T, because AD and FO is same. Okay, now whatever we needed from the graph we have already taken. Now let us recall the first equation. So what we derived in the first equation, students, V equals to U plus AT. Now what we are going to do is, from this equation, means what, the first equation, we are going to substitute the value of T. How? Let's see. So first step, I'm shifting U on the left hand side, so I will get V minus U equals to AT. The next step, I'm going to shift A, so what I'll get, V minus U upon A equal to T. So I got the value of A. So this value of A, I got the value of T. This value of T I'm going to substitute in the equation what I found out. Okay, so let's see the next step. So in the next step, see what I'm getting, S equals to half V plus U bracket V minus U upon A. How we got V minus U upon A? We substituted the value of T over there. Okay, we substituted the value of T. So see, again I'll repeat what we got. S equals to half V plus U bracket V minus U upon A. Now if you see the numerators, okay, we have 1, so any number multiplied to 1, okay, we get the number itself, so just keep that one aside. We have V plus U, V minus U. Okay, so just recall the identity A plus B, A minus B. So what is the answer? A square minus B square. So see what I'm getting, S equals to A square minus B square, that is V square minus U square, and in the denominator what we have, 2 into A. Okay, so we got the answer. Now what we have to do, we have to just shift the terms and write in its final form. So let me shift 2A on that side. So what I'll get, 2AS equals to V square minus U square, and when I shift U square on the left hand side, what I get, V square minus U square equals to 2AS. Now we understood the derivation of all the three equations of motion. Now let us take a summary where we discuss all the three equations together. Okay, so the first equation, it showed the relation between velocity and time. Now that formula is nothing but V equals to U plus AT. The second equation showed us the relation between displacement and time. That is nothing but S equals to UT plus half AT square. And the last equation showed us the relation between displacement and velocity. That is V square minus U square equal to 2AS. Students, I hope you have understood the derivation and the concept very properly. Thank you so much.